So I'm doing the problem 1D from the exam, which is the improper integral from 1 to infinity of ln of x over x squared. And so what I did wrong was I tried taking the square root of both the numerator and the denominator so that I could get improper integral from infinity to 1 over the square root of ln of x over x, which is just a simple u sub, which I already knew how to do. But that's not what I was supposed to do. I was supposed to use integration by parts, which I will show you now how to do. So, how you would solve this problem is that you would realize first, because ln of x, that's just what it is, but x squared in the denominator, that actually is just x to the negative 2, because any function to the power of a negative is just 1 over that function to the positive power. So like, for example, x to the negative 5 is just 1 over x to the 5th power. And the same applies in this case. So it's really just asking you to solve the improper integral from 1 to infinity of ln of x times x to the negative 2 power, which we'd use integration by parts for. And so how we would do that is we have the formula uv minus the integral of v du. And so uv, v du, how this works is that you choose u, a function which you can differentiate, and v, a function which you can integrate pretty easily. In our case, we would choose ln of x to differentiate, and then x to the negative 2 power to integrate. So, for our problem here, so u will be ln of x, because the derivative of that is just 1 over x, and then dv, because that's the derivative, is x to the negative 2, which we can integrate using the power rule. And how we use that, so x to the negative 2, when it comes to the power rule of integration, we add 1 to the exponent, and then we divide by the exponent plus 1. And so that will give us negative 1 times x to the negative 1 power. So our v is negative x to the power of negative 1. And so we just use our formula, uv minus the integral of v du, and we get ln of x times negative x to the negative 1 power, which would simplify that. And that's just negative 1 over x. And make this even easier, which I don't know why I didn't do in the first place, it's just negative ln over x. And then that minus the integral of v du is negative 1, or negative x to the power of negative 1 times 1 over x, which again, to make it simpler, is just negative 1 over x times 1 over x. And when it comes to integrals, whenever there's a constant in the integral, like whether that's, in our case, it's negative 1, but it could be 3, 1,000, 1,000,000, doesn't matter, you can take it out of the integral and then keep it on the outside. Instead of because say we didn't have ln of x and over x here, that would just be, the integral would be negative times the integral of 1 over x squared. But in our case, we have two terms here. And negative ln of x over x minus the integral, we take the negative out. That means that this becomes positive, because the negative times the negative is a positive. So we really just have the integral of 1 over x squared, which is also just what we had here before, x to the negative 2 power. Give you the bounds there. And then we don't even need to use integration by parts. This is just a simple integral. And we get negative ln of x over x plus negative x to the power of negative 1. And again, take the negative out, make this a positive, negative ln of x over x minus 1 over x. And so, because this is an improper integral, we're evaluating from 1 to infinity, but what we do is we take the limit of whatever variable, arbitrary, do b, limit as b goes to infinity, and we apply it to these terms. So clear some space here. Make sure y'all can see. So that would be negative ln of infinity actually we'll make bx, sorry. Then we can substitute that in. Minus or plus ln of 1 over 1 minus one over infinity minus 1 over 1. So on the left side, so because ln of infinity grows slower than infinity, this will end up going to 0. And ln of 1 is also 0, so it's just 0 plus 0. And like I said before, so because in this case, ln of infinity, like those are both functions, or that's a function, and ln of infinity will eventually go to infinity, but it grows slower than just infinity itself. But it's the same principle here with 1 over infinity, because 1 stays constant, and then infinity just grows to an infinitely large number, and that will make this also 0. And 1 over 1 is just 1. So, simplify here. It's just 0 minus, this is 0 minus 1, that'd be negative 1. So 0 minus negative 1, which gives us our final answer of 1.